Good morning, everyone. Sorry about that. I apologize. There was something going on here in my office. I delayed a little bit, but welcome to our Zoom lecture. If this is your first time, we started the lecture last week. I plan on sharing last week lecture recording. Some folks, for some reason, they missed the first session. There is a recording for that. Before we get started with our session this morning, I want to make an announcement, and this in regards to the access code to MyLab and mastering. Please use the temporary access code. It is good for 14 days. All right. If you don't have access code at the moment, if you haven't purchased the access code either from the company, just sign up. Just go in on Canvas and try to do the assignment and select the option for I do not have the access code. You will be assigned a temporary access code, which is good for 14 days. That way you will be in a position um to do the assignment as we go along. Other than that, if you have the access code, I understand what you get when you purchase the book from the bookstore is the claim code. I called the company last night and I was told the code you get from the bookstore website is the claim code where you need to go elsewhere to get the access code. I'll figure it out. This morning I went to talk to the manager and she was not in. I'll go again this afternoon and get clarification on the difference between the claim code and the access code. Other than that, I talked to the Pearson company, and at the moment, because of what's going on, they don't have 1-800 number for students, but for instructors, they are able to talk to a real person for assistance. But for students, I will share the link for chat. You can chat with somebody on real time. All right. If you have any issues, they say somebody, Jason, thank you. Say they email the access code and it worked perfectly. There was somebody who brought to me, thank you. I guess probably it had to do with an individual account. I know somebody who is taking the course right now, say last semester, she had an issue with her individual Pearson. But if you have an issue, please let me know. Without wasting my time, let me just shift gears to our lecture presentation where we stopped. We went as far as the uh, elements, all right, elements on the periodic table. What you see here, these are just few elements on the periodic table. And what I like to recommend to you is just learn the first 30 element, knowing the symbol, the chemical name, all right, and probably the position on the periodic table. Don't memorize the number. It's good to know, but in the exam, will give you the periodic table. Uh, you have seen this before. You have seen the names you see here before, but it's good to know where why sometimes the chemical symbol do not represent the chemical name. It has to do with the origin of, how they discovered or when they discovered the first element. For example, sodium, you may expect to be SO, but for sodium, all right, it is not S or SO for that matter, but the chemical symbol is Na, based on the origin of the name. Natrium, it could be Latin name, it could be Greek name. The symbol could be the first letter of the first two letters of the chemical name. Chemists, they are very particular on how you represent these elements. Always pay attention. It got to be, all right, it got to be in the right notation. always uppercase. I've seen before a student giving me a chemical symbol for sodium like that and say, no, it shouldn't be like that. This means something else. Avogadro's number, you'll see that later on, all right? Or maybe calcium, you may think that you can have that. No, it will not work like that. You have to learn uh, until you understand the way to present the chemical. So this one is natrium for sodium. We have potassium for kalium, K, all right? And so forth for hydrogen, for carbon, you need to learn those chemical symbol. That's coming up down the line, all right? Now, elements combine to form compounds. They combine to form compound in specific ratios, such as H2O, made up of two hydrogens and one oxygen. We call these the constant law of constant composition or law of definite composition, which states that when elements combine, all right, to form compounds, they do so in specific ratio. You will not see, for example, the chemical symbol for hydrogen being chemical symbol for hydrogen being H3. It cannot be H3 for that matter. You have to have the chemical right chemical symbol. So that is the hydrogen, two hydrogens and one oxygen for H2O. And you have to know there are two couple of laws. One of them is the law of definite composition, the law of mass conservation, which states that matter cannot be created or destroyed. Please have index card so that you you write down, divine, and commit to your memory the definition of these laws. Now, I explained this last week when I drew the classification of matter as either pure substances, mixtures, and mixtures can be heterogeneous, homogeneous, heterogeneous, homogeneous. You should be able, all right, you should be able to define what heterogeneous is. Means you have two or more distinct phases, two or more distinct layers. For example, a cookie with resin in it, right? That is an heterogeneous mixture. A mixture of concrete and cement, that is an heterogeneous mixture, all right? As opposed to homogeneous mixture. Somebody is asking the question, these slides are already up. So the PowerPoint slide you see here, they are under the modules. They are under the modules. Somebody is asking where to get the lecture PowerPoint slides. I do have them on the modules. So heterogeneous mixture. Given an example, and homo, you should be able to give examples of those. We can have here sand, all right, give you sand plus H2O. Alcohol, we can have alcohol plus H2O to give you example. Air is an homogeneous mixture. Alloy is an homogeneous mixture. Wine, to give you an example, there is sugar in there. You should be able to classify an element as heterogeneous. I won't be in a position to give you all the list of homogeneous, all the list of heterogeneous. Understand the word hetero, what it means. If the thing gives you more than one, then heterogeneous. I think this is the countertop or something, granite. This is heterogeneous because there is what? there is white spots, black spots, or gray, as opposed to homogeneous mixture solution of, I think this is copper 2 sulfate, form homogeneous. So that's what, just to recap of what we talked about last week. Now, any question on classification of matter? Any question on classification of matter, please go back to classification of matter as solid, liquid, and gas, note their properties, and classification of matter as heterogeneous, homogeneous, uh, and pure compound, that is compounds and element. Yes, Hans, these already they are available on Canvas. Thank you. Let's look at the properties. Property here. Let's define the word property. This is characteristic. You define this character what? Characteristic, feature, all right, feature, use, defining or describing, all right, describing matter, all right. A characteristic feature, green, apple, you're using the color to define that. Rough surface, you are describing, all right. Smooth surface, it's dividing the textures. It's viscous, you know, those are the terms used in the definition of properties, and it can fall into two categories: physical, chemical, and there is what we also classify this as either extensive or intensive. Probably you have seen this before, but we also have extensive and intensive. Physical properties, right? These are the physical, it has to do with, here, we have physical properties. Physical properties here are those properties which do not involve chemical changes or chemical reaction of matter, all right? Physical properties do not involve chemical changes. So if it involves a chemical change, chemical reaction, and then it falls into chemical property. You can observe this without changing the chemical substance. For example, color, this is a physical property. When you see a green apple, does not mean that you will change the chemical makeup. Or do a density of H2O, you can measure that, but does not mean you will change the chemical makeup of the substance. Melting point, boiling point, hardness, for example, those are physical. It has to do with the physical observation. Please underline the word observe. If you can observe, if you can measure without changing the chemical makeup, then this or that is classified as physical. I've seen students just making mistake and saying that since melting involve a lot of heating or boiling involve a lot of heating and something changed from liquid to gas, maybe some chemical changes took place. No, you need to understand. When I was past Tuesday, we went through physical changes by which you can separate mixtures to pure substances, and there was distillation. This is the distillation apparatus. You will, down the line, if you will proceed all the way to organic chemistry, you will have, or chances are, you'll perform experiment on distillation, separation of pure substance. I mean, mixtures to pure substances. Now, chemical properties can be observed into another substance. A property, flammability, all right? One common property you'll see is flammable. If something is flammable, it involves chemical reaction. Non-combustible or combustible, those are chemical properties we use to define burning, if it is flammable, such as acetylene or oxygen to form H2O. This is a property for a gas such as methane. So here is the key term you need to understand: difference between physical property and chemical. So here is when a substance is changed from one substance to another. We started with two pure substances here, hydrogen and oxygen gas, to form what? To form water molecules. In this case, we end up with different substance other than what we started with. In the text, we have extensive explanation on those two types of properties, all right? There is, apart from that, this is a new term here when we have a parallel between intensive and extensive. For physical and chemical, you can read that. Now, intensive properties are independent of those properties which are independent of the amount of substance that is present. I've underlined here the word independent, intensive. What does this mean? It does not depend on the amount. Let me give you an example of, intensive. Density. This is an example, not of water. Density of any object, any substance is independent of what? The amount you have. We may have 100 ml of water. We can have a gallon of water. We can have 5 liters of water, still the density will remain the same. This is independent of the amount we have. That's how you look at the intensive property. Melting, whatever we talked about in the previous section can also be used to classify intensive and extensive. How can melting be independent of the amount? If you have an ice cube and we have 100 pounds of ice, still the melting point will be 0, 0 degrees Celsius. It will start melting at that particular temperature for a pure substance. I'm just using H2O as an example. It will always melt at 0 degrees Celsius, no matter how much we have for an ice. Likewise, for boiling point, maybe melting point for that, boiling point is another example of intensive. It is independent of the amount of what? Independent of the amount of H2O we have. For example, it will start boiling at 100 degrees Celsius. Whether you have 5 ml, whether you have a liter, boiling point of H2O will always be 100 degrees Celsius. So it is independent of what? The amount we have. Versus now, all right, versus we have, several other examples of intensive properties: density, melting point, boiling point, all right, freezing point is the same as melting point. Intensive, they are independent of what? Independent of the amount of substance we have. Extensive properties are dependent Examples is mass, all right? Mass, how comes that mass is, we say that it depends. 3 grams, if the procedure in the lab calls for 3 grams and somebody is weighing 10 grams, you know which one will be more, all right? Extend, this is how I program my mind, that extend is make it peak, you know, like peak, it extend. But independent is just right there, it does not change. So mass volume, volume, if I have 10 ml versus 20 ml, you know which one is has large amount of liquid reagent in question when we talk about the volume. 10 ml is more compared to 20 ml compared to 5 liters and so forth. Energy also is dependent, right? Amount of energy you get. 4-cylinder car versus 32 piston car, if you may think, panning of gasoline, you can guess which one gives you more energy. It is independent. It is dependent on the amount you have. So energy give you example. So a question in the exam could be either which one of the following is extensive property, which one of the following is independent property. You have to know what is the definition of independent property, or if it is structured, divine intensive property, divine extensive property. I may give you few examples of that, all right? I may give you a few examples of that. Let's see, this is a learning check. When we say that lead is denser than metal, and then than aluminum, lead is denser than metal, it's a dense metal than aluminum. Are we talking about extensive or intensive? If I look at here, we are talking about density, and density is intensive. So thank you, Witt, Clark, Isabel. So these are the kind to give you an idea of what you expect, not necessarily that, you know, straightforward, that it got to involve critical thinking. This is too much, but it's just right here. If I have this, and then I know that what I need to underline is the density. Denser is density, but somebody will fail to connect this with what is the word you need to focus. It's not about the length. It's not about, you know. The correct answer is intensive. Thank you. Now, having gone through the intensive, extensive property, physical property, chemical property, we have what we call change. If I have, let me just illustrate this, and then I have A or something here. A with a star. That means we are moving from point A to point P. And a change here could either be 1, physical, or 2, chemical. That a change moving, you know, it's not like a change point A to point B. Something happened. A change, you know, when I say change the position, that means you move from here to here, as opposed to a property which you have to look at. All of that changes could be physical or chemical. A physical change is a change which do not involve the chemical composition. A change here, physical change. How do you recognize a physical change? 1, chemical makeup. Is not, I should have capitalized this and Altered, that means change. You do not change the chemical makeup in physical change. No change in chemical composition. You can also look in terms of reversibility. It got to be reversible. You have to ask yourself, is it reversible? If it is reversible, then that's a chemical change. I mean physical change. If it is reversible, it's physical change. Change of state. This change of state is from solid to liquid to gas, from liquid, all right, to gas, or from liquid to solid. Change of state, solid to liquid, and you need to know those. Somebody asked a question here, Floyd. Well, I don't know if you are asking about a lab. We do not, we're not dealing with top hat. I guess maybe you are referring to, all right, Pearson, but somebody responded to you. Lucenspool responded to you. I guess that is the top hat. We are taking the lab right now, but nevertheless, the change here being referred to is melting, freezing, vaporization, evaporation, freezing, condensation, sublimation, right? The volume. Examples of physical changes here is if we have here solid, liquid, and gas right here. I want you to see the changes here. This is melting. This is a physical change. And then coming freezing, this is a physical change. And then vaporization or evaporation. We have condensation to condense, coming back to liquid. This is liquid right here. And we have here deposition. This is a physical change, and we have here solid to gas without going through the liquid state, sublimation. To give you examples of the physical changes here, we do not change the, if we are referring to H2O here, we do not change the chemical makeup. It will be water molecule, it will be water molecule, it will be water molecule in gaseous state. So if it is reversible, all right, if it is reversible, if you don't change the chemical makeup, then you classify that change as, some folks are in the waiting room, sorry about that. Let me let them in. So the changes can be physical. Chemical change now. And by the way, apart from what we have here, some I've seen before physical change here. Is grinding. If I have large crystals of sugar and then I grind, I'm just reducing the size of the crystals to small pieces, but I don't change the chemical makeup of water. Here, shredding, for example, if you shred a piece of paper, all right, I don't change the chemical makeup. Look, I don't change the chemical makeup. I'm just reducing into small pieces so that you say, he didn't mention it. Ask yourself, did I change the chemical makeup? If not, then that is a chemical, physical change. Here, I want to just shift gears to chemical. This is chemical change, chemical change. All right, chemical change. this involve, all right, it involves the chemical makeup here, chemical is altered. Chemical makeup is altered or changed, right? Chemical makeup is altered or changed. So we say the chemical makeup. This irreversible. That means you cannot take it back. The change is irreversible. Combustion, if you burn something, this is an example. All right. Digestion, fermentation, that means you ferment. If you ferment sugar, you're not gonna carry it back. Chemical change, combustion, digestion. If you digest pizza, frying, if you fry an egg, all right, you're not gonna get back your original egg. You fry, then you alter the chemical makeup, combustion, oxidation, decomposition, and just giving you a few more examples on the whiteboard here. You need to know the chemical changes, chemical change. Ask yourself. Any question on the physical and chemical change? Any question? You can read more, understand what they are, or you'll be given examples or more in the class text. Read more on that. So physical change, changing from solid to liquid. We have looked at that before. All right. Chemical change involve chemical reaction. It involves chemical change. Corrosion, new substances are formed. If you look at the appendix here, placing it in nitric acid, oxidation will take place and we end up with new substances. Examples on physical and chemical change. Plants is the following change physical or chemical. Plants make sugar from carbon dioxide and what a chemical change cannot tell. Let's see, there's regency. All right. Somebody say A. Bria Clark, you have a question about decomposition. Decomposition reaction, that is a type of reaction. Yes. I don't know if you're doing the lab or you're doing something else because I know lab, there are a couple of chemical reaction, decomposition reaction, that's just chemical change. Thank you. Keyword is make sugar from, they're making sugar from what? Carbon dioxide and water. So these are the starting reagents, carbon dioxide, and we end up with new substance, which means the reads, and of course we cannot get back our original without that make to start from. So that's what I look at. Thank you. So it's involved chemical change, chemical change. There is a lab you will do if you are taking lab right now. I believe there's an experiment on separation of mixtures. I talk about separation of mixtures and I gave you these examples: filtration, distillation, chromatography. Yeah, well, down the line you may do this, may perform experiment on chromatography, and there is a lot of types of chromatography, but the most important you will encounter in undergraduate here, filtration. Just you know how to filter, you always filter stuff at home. A separation of solid, pouring mixture so that you separate solid from liquid, you end up with the filtrate. All right. What goes through, if we have a filter here, and then we have solid right here, and then you are pouring your mixture here, you end up with liquid right here. We call this filtrate. That means you are filtering whatever came, and then this might be residue. You know, these are the for carbs, which will help you be a good chemist. What do we call this? Whatever goes through the filter, then this is filter or filter paper. Let's be politically correct and say filter paper. When you pour, the liquid will go through and you end up with the filtrate. We call this filtration. And then the distillation, I showed you the distillation apparatus earlier on, but the most important, distillation and filtration. In filtration, solid substances are separated from liquid and solution is shown on my whiteboard, right? There is the filter pouring the solid. You see the filtrate is in the beaker now, it's clear, and the solid remain on the white filter paper. You have done this before. I know you have done that. Now, there is the decantation where you pour. Somebody was, explained to us last week, difference between filtration and decantation. Decantation is just pouring. So if I have my, oh, you cannot see this. I'm sorry about that. Let me just try to use my phone. I can just pour without using the filter paper and the solid will remain on my phone. We call that procedure decantation. Decantation. You may have performed an experiment. You may have performed an experiment where saying decant your reagent or your solution. It's just pouring and you remain with that. As opposed to distillation, which is you separate mixtures into pure substances, taking advantage of their different boiling point. If they have different boiling point, you can separate using distillation. Alcohol boils at 78 degrees Celsius, H2O boils at 100 degrees Celsius. So if we have a mixture of alcohol and H2O here, we boil, alcohol with lower boiling point will come out fast, will collect here. Of course, water will get in here to freeze to cause condensation of the vapor. Always the distillation apparatus, there is a thermometer here to show you, the temperature, so that you know which liquid you are collecting. If the temperature remains constant at 78, and we know the boiling point for alcohol is 78, we know the liquid we are collecting here is H2O, alcohol. If the temperature rises to 100 degrees and remain at 100 degrees Celsius, we know whatever we collect here is H2O. So that's simple distillation. A simple distillation is what we call fractional distillation. You may see that in higher level chemistry courses. Chromatography, all right? Chromatography is a technique used to separate mixtures on the basis of the difference in their mobility, all right, to adhere to services. Substances are separated based on their mobility in through a stationary phase. We call this a stationary phase. And the entire apparatus is the chromatographic column. If we have a mixture right here, you see it based on how the substances move through the capillary or chromatographic column. The one with greater mobility will be separated from the one with less. So this might have higher molecular weight, this might have smaller molecular weight, and we collect the mixtures. That's how it works. It's as simple as that. You may use that down the line if you get into a research field where chromatography is used. Any question on the separation of mixtures, please read those. You will see I will not ask you anything outside what I just went through on the filtration, distillation, right? You need to read that and understand. Let's shift gears into nature of light, nature of energy. And we define this first as energy, should have a small, this is defined as the ability to do what? Ability to do work, or sometimes this is defined as the capacity to do work. We define energy as the ability to do work or capacity to do work. There are two most important types of energies you need to know, understand. There is kinetic energy, and this is what? Energy in motion, energy in motion. The energy possessed by moving object. Kinetic energy is energy in motion. This is the energy possessed by moving object. Compared to PE, which is what these are stored, this stand for, first of all, PE. What is PE? This is potential energy, potential energy. And simply this is defined as the stored energy. It is the energy possessed by object by virtue of position or chemical composition. It's stored energy. Gasoline has stored energy. When we break the chemical bonds in gasoline, we end up with the energy which can be transformed into other forms of energy. So those are the two most important energies you need to understand: potential energy, kinetic energy, definition of energy, as well ability, capacity to do work. And work is just the energy transfer. I know sometimes we confuse the term heat, all right, and temperature. Heat is the energy used to cause the temperature of an object to increase, right, and force just gravitational for that. There are two forms of energy. I explained this. Energy is energy in motion, energy possessed by moving object, and kinetic energy can be calculated using the equation Ke equals to half mv squared. Yes, it's a simple equation, but you need to understand what does M stand for. Mass, and V, this is velocity. You may be given, this is the same as the speed, all right? You may be given the speed, which is velocity, and this is the square, of course, and the mass. This is always in kg. You need to change the mass to kilogram, and you need to change this to meters per second. So if it is going in miles per hour, you need to change that using the appropriate conversion factors based on the units of energy. Remember, we are trying to get energy, and there is a relation, just to bring to your attention so that when you will be doing homework assignment, maybe calculate the kinetic energy, and you are given the values, you need to know that, all right, how do I change the speed from miles per hour or kilometers per hour to meters per second, so that when you plug in this equation, you'll get the correct answer, the units for energy. Potential energy, PE, is the energy possessed by a virtue of chemical composition or position. We can convert, by the way, we can convert potential energy to kinetic energy, potential energy to kinetic energy. Yes, I'll give you the conversion, Lauren, I'll give you the conversion factors, but there are those which you are expected sometimes to remember. Like everybody knows there are 24 hours in a day, right? How many seconds are in 1 hour and so forth. You may not really get that, but I'll give you the conversion factor for that. Thank you. So coming back to potential energy, it can be converted to kinetic energy. You see here, the message here from this illustration is potential energy can be converted to kinetic energy. I'll leave these to physics. You will see in physics. Now, there are, all right, this is what I was just highlighting on my whiteboard here, that why do we need to do that? So that we can relate the SI unit for energy, which is joule, to the units you'll end up when you plug in your values using this equation. So when you plug in kilograms here and meters per second, this is what you'll end up: kilogram times meter square per second square, which is equivalent to 1 joule. So we can now relate to SI unit for energy, which is joule. This is a common kilojoules, and of course, kilo, you know the prefix, 1 kilojoules equals to 1,000 joules. You can now move from joules to kilojoules and something else. So know this, what is going on here. Why I had to bring that earlier on is you'll be given in a problem, not kilogram, not mass in kilogram, but mass in maybe grams, maybe in ounces, and maybe the speed will be different because of this. Now, there is, by the way, this is not the same as this. There is a difference between uppercase skull and, look at this, 1 calorie is equals to 1,000 lowercase calorie. You see that? What does that mean? This is the unit used by nutritionists. And you see nutritional calorie, anything you see on, be it maybe on the subway and they declare their energy content of their food long, or any other drink, maybe your soft drink, a can of what? A can of soda. If it is 170, let me give you, if it is 170 calories, what is being referred is this one, it's this lowercase, they use by nutritionists in food we eat. So technically, we are talking about 170,000 lowercase calories. That is what you will consume in 1 can. And there are some people who take 5 of them a day. So you can imagine you need to work out. I was thinking that probably they should start labeling using the lowercase so that people get scared of it. Like, I don't want to consume all those calories. With that, with the units, 1 lowercase calorie is equals to 4.18 joules. Sometimes you may be, what is the unit in those? You can use that, all right? I'll give you this, by the way, if need be. I'll give you this conversion factor you can use in your, all right, you can use in calculation. Let's see, a baseball weighs 5.13 ounces. What is the kinetic energy in joules? If these balls travel, when it is thrown by a major league pitcher at 95.0 miles per hour. So when I look at this, Why do I have 95.0? It's because three significant figures. So I know my final answer should have three significant figures. With this calculation, you need to use this equation: kinetic energy equals to a half m v square, a half mv square. So you need to change the mass to kilogram. So you can just change, first of all, 1 ounce equals to how many grams? Is it 453? Somebody check. Somebody can Google out what is 1 ounce. Use the chat window, please. You can Google out what is the mass. What is the mass in grams of one? We just have to convert that. Anyone? You can Google out. It's okay. You can Google out. One kg. Oh, somebody had, all right. So we can just use that. And if that, and then you say 5.13, you do the calculation, you're changing the ounces. So you want to dimensional analysis. You want to get rid of ounces here, all right? You want to remain with kilogram at the top. So what I need to do is plug in from this conversion factor if I'm given this, somebody, if you cannot see 1 kg, if you cannot see that, somebody gave us this, 1 kg equals to 16 what? 16 ounces. So this is right here, it's not 1 kg, but yeah, 1 kg.
Professor,
Yes,
it's not 1 kilogram is not 16 ounces. 1 pound is 16 ounces.
1 pound,
Yeah. A kilogram is 35.27 ounces.
35.27
35.27.
equals to 1 kg, correct?
Yes.
So if we set up either, I don't know where you get that 16 ounce, but if we have this right here, the conversion factor we cancel out this and cancel out that. This will give you the mass in kilogram. 5.3 divided by 35.5. What is the value for that? Real quick, somebody put us on the chat window. What value is that? Chat window, please change that to mass in kilograms. 5.13 divided by 35.270. So we have 14, no, 0.145. This is kilogram. We need to change now the miles per hour to kilogram. You can change the miles fast and then change the change. You can change the miles fast, like 95.0, right? Miles equals to how many meters? Equals to how many meters? For this, 1 mile equals to 1.62 kg. No, kilogram, kilometer. How do we change that to miles? Or rather, what you can just say 1 mile equals to how many meters? Somebody on the chat window, please. How many miles are in 1 meter? This is the kind of exercise you will do, and you better know it right now. Yes, in the exam, of course, I'll give you the appropriate conversion factor, but for homework, you will be on your own. So what is the appropriate conversion factor? Is, no, that sounds like Trinity, that sounds, I don't know what that value is. Yeah, that makes sense. Yes, thank you. So if we have 95.0 miles, we can just convert that to miles here, convert here to meters. So I'm setting up, and depending on how you get that, somebody just, let's just go straight to meters. 1,609, all right, 609 meters. So we cancel that, You multiply, all right, you multiply by what? Multiply by 95. Multiply by 95. 95.0 times 16.0, 1,609. When you multiply 16, so 152, all right, 152,887, just round out that meters, you can, so meters. We have that 1,052, so kinetic energy is a half times whatever we had in here is what, 0.145. So this is 0.145 times 152,000. It was 152,887 over 36. It was per hour. But remember, you need to square this. You need to square that. And the unit will be kg times meter square per second square. That will be the units you have in there. Yes, thank you, Gonzalez. So what we need to do is have that value. What do you get on your calculator? I need to find my calculator here so that we can with. So let's all do together. What do you say? So you have 130, 130, just you got 130.76 kg times meter square. What this means is understand from what we define 1 joule equals to kg times meter square second square, which is the same as 130.76, 130.76 joules. The question could be in kilojoules, so you need to change from kilojoules. Some question may ask you that. So if you look at that, somebody who doesn't pay attention to the unit conversion will think that I'll just have to plug in the mass and plug in the, and then you get the, and of course, hopefully, Jose Conini, you consider this 1/2 right here. So the point here is there are some techniques, some mathematical skills you learn somewhere or you are expected to have learned somewhere that you will have to apply here, which we will not cover. So how will you go about that? It's by practicing, by reading. If you don't understand, get assistant and say why. Like for example, this one, I can guarantee you that you will not see in the lab, or not lab, but in the text how to change ounces to, you may have table, or how to change miles to, to kilometers or to meters. They expect you to have known that. So that should be a red flag that you need to do some more work if you're forgetting that. Now, what we are going to look at now is shift gears to significant figures and stuff like that, and the numbers. Numbers are critical in scientific community in the sense that numbers play a major role. all right? They give us the quantitative. We are in the middle of the pandemic. They talk about the numbers and they convey a lot. So for our calculation, we need to know how to record or report a number with the correct number of units and using the correct number of significant figures, and the uncertainty, of course. So this is what I want to highlight on the significant figures. And of course, we will look at the dimensional analysis later on. We'll look at the dimensional analysis, which we just use the dimensional analysis in our calculation. Let's see. In the previous section, we used that. Measurement. A measurement consists of two things. Let's define first of all, or understand what a measurement is. A measurement consists of a number. It consists of number plus a unit attached to it. I mentioned this before, and there are three main types of measurement. You will see there is the metric, which we use in the lab. There is the SI, which you will see System International, stand for System International, and 3 here, the English, all right? The English system of measurement. We call these systems. Let me just say systems. When you look at those, you may think, what's the difference? They are different systems. There are different systems, system of international. So we have these, right here. This is what we commonly use in labs when you measure the volume of a reagent, use ml. When you measure the mass, you use grams, temperature, degrees Celsius. But when we go home, we use English system. When you pull by the gas station, you use gallons to dispense gasoline, which is not metric. The reason why we use this metric system is it has a pace unit. We talk about the pace unit, which we can expand or reduce in the metric. But for SI, these are the pace unit, about 7 of them are for meter, kilogram, G, second, and mole. All these are the pace unit in System International. Once in a while, I see question asking, what is the pace unit for, in metric? What is the pace unit in SI? You need to know there's a difference. For example, here, metric, in metric system, the pace unit for mass, all right, this is grams. The pace unit for volume, this is liter, all right? It might be the same at some point, but if you look at the mass here, it is kilogram for SI, it's gram for metric system. You need to know that what they stand for. Metric system, the base unit used in this is because of its advantage of expanding the pace unit and either reducing or increasing. In metric system, gram is the base unit, meter the base unit. What do we mean by pace unit here? We can expand this. That is the pace. That is where we are starting. Let me give you a scenario here. Kilogram. Kilogram means you have expanded the pace unit by 1,000. You know where we are going, right? You know where we are going with the prefixes. This is 1,000 gram. When we say kilo, I can say megagram, which is 1,000 or a million gram. Teragram, that is times 1 times 10 to 12 grams and so forth. We can expand or reduce the base unit in metric. That's the advantage of it's a decimal notation system. So the advantage as opposed to SI, we do not include that. Please differentiate that. Among, this is something we will look at it later on, is a unit used by chemists to express the amount of substance. And it represents this 1 mole, you know, the Avogadro number 6.63 times 6. Represent this amount of item. If I have 1 mole of student, that is the amount of student I have in my section. We use this in chemistry. We'll cover more. We will use this number down the line. Later, cubic for volume. Oh, I had used the prefixes earlier on, which mainly used in metric system to expand the base unit. You need to learn this. Use index card. All right. Yeah, this is Avogadro number. And by the way, Nelson, Avogadro number. There's the Molde, which is from 6:02 a.m. to 6:02 p.m. every October the 23rd. That's Molde in Avogadro number. You can Google out Molde, you can read more about that. So here are the prefixes I was talking about. You need to memorize these. These are prefixes used to expand or reduce the base unit. Tera, so I use times 10 to positive 12, expand gigabytes. How many gigabytes is your, your hard drive? Talking about the storage. A byte is a unit for storing information in computer. So whatever you're shipping for your smartphone, you may want to look at the storage. Let's talk about the gigabytes, terabytes, kilo, milli, micro times 10 raised to 6. I've seen question on this that they might ask you that in a metric system, this symbol represent what, or you may be given the numerical value. What I'll recommend is learn the prefixes, learn the name, what they represent. When we use centi, what is the numerical value for that? The author uses watts, which is unit for expressing the electric watts, all right? Or you can use gram for that. So paying attention what they mean. Don't let this fly. It will come back again. It will come back again. Learn the names, what they represent. I guess this symbol here, Greek symbol new, represent micro, because if we use M and M, it may bring confusion with milli. So when we use this and that, it may differentiate milli from micro, milli from micro. All right. So here is a learning check. What exponential notation did the following abbreviation? D for, I think D is for Daisy, say Daisy, and 1 times 10 raised to what? M for mega, you know, P for pico, all right. Pico, it's just from the previous one right here. You see this? This is for pico, which is times 10 to negative 12. Deci, you see this? D for deci times 10 to negative 1. It's negative 1 here. This is times 10 to positive 6. It's uppercase M right here. So you may be asked, anything around either the abbreviation, either the name or the meaning you have, just to give you an idea of exponential notation to the following abbreviation. So pico times 10 raised to negative 15. Is it 15? Yes, 15. No, 12. This is negative 12. No, the prefixes used for that. Now use appropriate metric prefix to write down the following. I just say this is A right here, A, P, and C, A, P, C. From this question right here, this is what happens. Just to give you an idea of what can be, what you may see in the quiz or in exam about the prefixes. Now, follow-up question, use appropriate metric prefix to write down the measurement without use of exponent.
Can you repeat that?
Yes, use the appropriate metric prefixes to write the following measurement without using the exponent.
Oh, I'm sorry. I thought
Prefix,
it was,
yes,
I
right.
thought you had a question.
Yeah,
Sorry.
4.7. So you'll say, yeah, Jason, let me see. Yeah, times, yeah, you used that 4.7 microgram, thank you, 1.8 picometer, thank you. Yes, it's just understanding those prefixes. So you may see the terms you have there as multiple choice, and then of course, you will know what to select for that. That's just shedding some light on the prefixes concept, how you can be tested on prefixes used to expand and reduce the base unit of measurement. Mass, we use kilogram. Length, we use meter in both SI and metric, but mass in SI is kilogram, but in metrics we use gram. Our volume, of course, is the amount occupied by an object, and we can use volume. We can determine the volume of regular object using the equation, which is length times width times the thickness. You know that this is for regular object. For a regular object, we use volume by displacement. You know what displacement is. It's just take the initial volume, pour the liquid into initial volume, drop the irregular object. The volume will rise once you have the object in there. You do the calculation. Final volume minus initial give you the volume of irregular object. Depending on the classware or instrument using, you can have units as in ml or cubic centimeters and so forth. You can read that. As far as chemistry or labs are concerned, these are just few classware. What you see on PowerPoint slide here, few classware you will encounter, you may have encountered in the lab, graduated cylinder, the volumetric flask, we call these volumetric flask, and more precise. And by the way, you may wonder that, how will I measure the volume here, yet I don't see anywhere calibration? What they mean, or there's a calibration mark, there is an H on the neck right here, which means if I have, for example, 10 ml, look, 10 ml volumetric flask, means if I pour my reagent into the flask to the calibration mark on the neck, I have exact 10 ml. That's how these volumetric, and they are more precise, by the way. They are more precise than either the graduated cylinder and the string. I know you know how to use this. I know everybody knows you are familiar with this. You get a shot. I'm gonna get my second shot tomorrow. You know, they use the string, the volume. Now coming this, this is calibrated in such a way that the initial volume always 0, 0 is at the top, 50 ml or whatever the calibration is at the bottom right here. So you drain your liquid reagent. And the volume you read is not a function of whatever remain here. It is whatever you dispense. So if it's starting from 0 to 5, that means you have your 5 ml dispensed into your receptacle. Dispense into your receptacle. I know we are on remote. You may be taking lab component for this course. You're doing things remotely, and you may not get a chance to have hands-on this period. When Corona is subdued, is gone, you will come on Canvas and you may use this and understand how it works. This is called the stopcock. You open, shouldn't be leaking. These are just few apparatus using to measure the volume. We use thermometer to measure the temperature, and always, you know how to use that. We use degrees Fahrenheit at home, but in the lab we use degrees Celsius. Be familiar with those two systems for expressing the temperature. Kelvin, there is the Kelvin, there is the Fahrenheit, there is the degrees Celsius. There is the Kelvin, there is the degrees Celsius. These are just what you see here at the boiling point of what? H2O and the freezing point. All right. You should be able to convert from one scale to another scale. Let's say from degrees Celsius going to Kelvin, like that. Going to Kelvin. Kelvin equals to degrees Celsius plus 273.15. I know you may have used this before. This is the equation for changing degrees Celsius to Kelvin. And of course, from Kelvin to degrees Celsius, all right, it is degrees Celsius will be Kelvin minus 273. Is that's the opposite of that, temperature conversion. Degrees Celsius to degrees Fahrenheit. That means you'll express your temperature in degrees Fahrenheit. It is what you are given times degrees Celsius, 1.8 times degrees Celsius. This is an equation plus what? Plus 32. It's just the equation for changing degrees Fahrenheit. I mean degrees Celsius to Fahrenheit. It is the given temperature measurement in degrees Celsius times a constant 1.8 before you add 32. Don't add 32 to degrees Celsius and multiply by. No, it's not going to work. I've seen one time in more than 10 years of teaching. I've seen one time where a student added 32 to degrees Celsius and they ended up with the wrong answer. That's what I want to mention to bring to your attention. I know you have done this before, temperature conversion from one unit to another unit. I've just summarized this right here, changing from degrees Celsius to Kelvin. You see from the PowerPoint slide, there are a lot of information. But if I summarize on my index, if you're using index or making your own notes, you see only I've just summarized. If I want to change from degrees Celsius to Kelvin, this is the equation. And by the way, I'm not going to give you all the equation. I may only give you this in the exam, and you should be able to use that. If you don't practice using this equation, chances are you will not know how to use in the exam. I'll give you only one. Use that. Likewise for this, if I want to change degrees Fahrenheit to degrees Celsius, that means degrees Celsius will be given by degrees Fahrenheit first. Look at what I'm doing, minus 32. and then over 1.8. It's just rearranging the first equation. Let me call this 1 and label this as 2, 1 and 2, to change from degrees Celsius. So this is just, too much simplified, but narrow it down to changing that. So I'll do that. Fahrenheit 9 over 5, that is what I had. That means changing from degrees Celsius, look at my whiteboard. Changing from degrees Celsius to Fahrenheit, this means degrees Fahrenheit equals, all right, 1.8. If you divide 9 over 5, I know somebody might say, oh, well, why am I looking to different numbers? I don't like fractions. I don't know about you, but I like working with something like this. Though there are places of decimal, and look at my what? Look at my parentheses. I know I have to deal with this fast before I add the two, and that's how you use this equation. And by the way, we don't have degrees Fahrenheit, degrees Kelvin. You'll never see this. You'll never see this. Okay, no. There's no degree. It's just Kelvin. But we have degree in Fahrenheit. So this is what I'll do for rearranging that equation. I know you can do this. Weather forecast predict that the temperature will reach 32 degrees Celsius. What is the degrees in Kelvin? So you can try on your own. Please plug in your calculator. That means Kelvin, not degrees Kelvin, but Kelvin is given by 31 plus 273.15. 273.15. That is A. Now, for degrees Fahrenheit, that is P right here, we are looking for degrees Fahrenheit. This means it's going to be 1.8 times 31, and then we do this fast, all right, plus 32. Plug in your calculator and you will end up with the correct answer for temperature changes. All right. Any question on temperature? I didn't solve a lot of problem on that, but I just set you the pace that this is what you need to do. Please make use of that equation. I know there are a couple of problems at the end of chapter problems on solving or temperature conversion. Now let's shift gears to density. Density is, we classified earlier on as intensity property, and it is the ratio, of course, we all know, the ratio of mass to what? I know somebody somewhere, all right? I know somebody somewhere may have difficult with the equation density equals to mass over volume, because that's what we're gonna be using. Density equals to mass over volume. And of course, the what you see here, what I wanted to see, density over volume here. Density over volume. Oh, the way I remember is if you make a heart, somebody, I don't know, if you make a heart with your, I'm trying to make a heart with your hands like this. I don't know how to make, I don't know, like that. I don't know how to make that. But anyway, this is what I wanted to bring to your attention, that mass, d volume, there is multiplication here, so that if I'm looking for density, the density equals to mass over volume. If I'm looking for mass, it's density times volume. There's multiplication right here. And if I'm looking for volume, it is mass over density, mass over density. So you plug out whatever you're looking for, you plug out. If you cover this, it will be mass over volume. If I cover this D, it will be mass over volume. If I cover this, it will be density times volume. That there are three equations. I may give you, or you may only be given that, so that volume equals to what? Volume equals to mass over density, and mass equals to density times volume, just to give you example. And these are the units. Depending on what units you are given, please pay attention to the units. What you see here, I will not, of course, I will not expect you to memorize the true values, the literature values for density for different substances. But I thought I could get the density of ice. Maybe they didn't give it here, but if you look at the density of of water, it is 1.00. This is the pure H2O. But the density of ice is 0.999. It's less than one. And that explains what happened when you put ice cube on your water, it tends to float. It tends to float. It's because of that, right? It's because of that. Now, the density of benzene at 15 degrees Celsius is 8 point, no, 0.8787 grams per ml. Calculate the mass of, oh, wow, this is a combo. This is a combo because there's a problem inside the problem. Here, you should be able to recognize or realize that the calculate the mass of. So if you think that, look at my whiteboard, if you think that you're going to use this equation and then you plug in the density and then you plug in the volume here, you are wrong. Why? What do we need to change first? Let me see by chat window. What do we need to do first? Yes, thank you, Catherine. Hope I pronounce well. Yes, we need to change this guy right here to leaders. And as I say, they may expect you, or you may expect it to remember this, that 1,000 ml equals to 1,000 ml equals to 1 liter. So we essentially we are talking about 150 ml, 150 ml. Somebody is saying, how do we end up there? You multiply this by 1,000, you multiply this by 1,000, 0.1500 liters. You want to get rid of liters, you want to remain with 1,000 ml here. 1 liter equals to 1,000 ml. You cancel that, and then the decimal point will move to 1. That's how you ended up with that. That's what we need to use now in our calculation, that density equals to mass over volume, so that we have mass equals to density times volume. So density is 0.8787, and it is grams per ml times 150 ml, so that ml and ml will go, and you will remain with mass in grams, mass in gram. What is the numerical value? For those who doesn't have a calculator, for those who have the calculator, just key in on your calculator 0.8787 times 150. All right, yes, 131.8. I will say 4 significant figures because of this 1, 2, 3, 4. 1, 2, 3, 4. Why do we have 0.1500? Why not 0.150? Why not 0.15? This stresses the fact that we should have 4 significant. And if I look at that, 1, 2, 3, 4, so it could be just like that, and that is grams. Thank you. Somebody is just maybe somebody was locked out and they're getting back. That is a good question, Jason. Multiple choice exam will be multiple choice, and of course, the one with the correct number of significant figures will come out. But the catch is now when you're doing the homework, if you key in the wrong significant figures, the system might reject that. I'm just saying, but for exam multiple choice, and you see that if what you see on the chat window, if this is A, I don't know if you can see, and this is, of course, you will say, why not this? I'll pay attention to, because times all the time, right? All the time, one of the multiple choice is the one with the all the digits you see on your screen, because somebody will not give it a second thought and say, this is wrong. I had to play with the significant figures. You have to play with the rules of significant figures. All right. Uh, all right. Now, we talked about, or I just mentioned significant figures. And significant figures are digits used to express a measurement. It does not mean that when you multiply numbers, for example, what we had here, when we multiply, you may think that everything in there is correct. No, we got to play with the number, with the rules of significant figures. And rules for significant figures is, before we come to exact, I'll come back to exact numbers. Exact numbers, first of all, I'll kind of come back to that, but we need to talk about significant figures before we come back to exact numbers, all right? Any question? If there is no question, I want to stop here today. We have 4 minutes and I don't want to start section 1.6. This has to do with the significant numbers, and significant numbers will follow you all the way to Chem 2, all the way to Chem 2 lab, all the way to Chem 2 lecture. They will expect you to have learned the significant figures. Even when we get to chapter 7, chapter 9, they'll expect you to understand the rules of significant figures and calculation. I'll start from here next Tuesday. Please do the assignment on the syllabi. Check it is available under the assignment. There's a document you need to sign. If you have a mobile device such as iPad, you can just do electronically and submit. Please do so by the due date. If you don't have the access code right now, just go in on Canvas, try to do the MyLab and mastering assignment, select the option of I do not have the access code right now, and you will be assigned a temporary access code. All the assignment you will complete during the temporary for 14 days will not be lost. You will pick up from wherever the 14 day will end for you, okay? So you have no reason as to why you cannot start the MyLab and mastering assignment. I don't know if somebody, let me just bring to your attention, please do not go to pearson.com and then you click on MyLab. That is a global. They call it global, and it will require you for the course ID. If you go to pearson.com and then you try to sign up, they will ask you for the course ID. So what I recommend is you go into, all right, you go into MyLab and Mastering, and MyLab and Mastering, and it will take you to the right scale. So if you have any question, please let me know, and and we'll get to that. Please do not click on, I'll come to assignment. All right, I guess this is for me. You will not see this. What I want to say is click on MyLab and go to mastering assignment. I had, I don't know if you still have issues. Somebody was asking me about the assignment, in particular, the dynamic study modules. Do not click on dynamic study module. It will take you to all those. So to start it or to call or access the study dynamic module, just click on the assignment and it will, all the 5 assigned dynamic study modules will be at the bottom, and they are available throughout the semester. So you don't have to go anywhere. Just click on the assignment, it will be at the bottom of the page. Otherwise, if you close to dynamic study module, it will give you all of them. So that's what I just want to bring to your attention. Other than that, the class is dismissed. I'll see you again next week. If there is no question, the class is dismissed. Thank you for joining in this morning.
I do have a couple of questions before we leave, just
Yes.
before you sign off.
Yes, thank you.
Yeah, so I had 2 quick questions, and then I have one about that mastering. So one, have you posted the syllabus quiz? Because I know that the due date changed, but the syllabus quiz isn't popping up for me.
The syllabus, it should be under the assignment. If I'm not wrong, let me see. Hold on. Let me share my screen. The syllabus check, is that what you are asking?
Yeah, because every time that I click on it, it doesn't actually show up.
Maybe I need to check something, and it is under the assignment. Let me see. Maybe the due date is not. It's under the assignment. Don't worry about what you will see right now. It is. You see here, right? Can you see?
Pull that up.
Go to under the assignment, and it will be the first, Canvas check syllabi.
See, it's not a quiz. That's why I couldn't see it. Okay.
Yeah. It's under the assignment. Yes.
And then, so one of my other questions was, I've had, whenever like I have a question, to get into your Zoom space, the only Zoom meetings that you have are these, like your lectures. And so it won't actually let me go into like your Zoom space to like ask a question or anything like that. And I was wondering if like maybe I'm doing something wrong for that.
It doesn't ask. It doesn't pop. It doesn't give you the chat window. What you mean? You cannot use the chat window to ask question on the chat window, right?
Oh no, that I can. But like outside of lecture class time, you have mentioned on your syllabus that like you're available from like 9:50.
Oh, okay. That is what you need to do. That is just send me what time you are available, and then I can schedule, because it differs from somebody to somebody. Because other than that, or you mean the office hour, something like that? If that outside, when you want to get in touch with me, the first thing is send me an email. For example, tomorrow is Friday, right? You get stuck. Maybe like you need assistance outside this. Send me an email and I'll respond that, okay, this is what it is. We start with the email first and say, do you have time? Or you can tell me, I'm available tomorrow at this time. I can tell you, okay, let's schedule a Zoom meeting. I'll schedule a Zoom meeting outside where we are, because what happened here, if let's say, for example, you have a question and I schedule a Zoom meeting with you in the class section, everybody will be notified about that there's a Zoom session going on right now, and everybody will try to say, oh, do we have a class right now? No. So it is outside.
The 9:50 to 10:50 you have on your homepage is by appointment only?
Yes, appointment. Yes.
Okay. And then I have a question about those dynamic study modules, because since you said they're available throughout the semester, I figured I'd click on it to take a look. But they're not open for me. I click it in a blank screen.
Oh, they are not opening. That is the second one. I'll find out again. I'll get back with the company, because last night when somebody brought to my attention, I say, can you look as if you are a student? And they say yes. I'll go again and make sure that they are available, because when I look from my end, everything is assigned, and I do have available. You can see available until always available. Can you see my screen right here? But I don't know why.
Yeah, Jason, I was actually the one that emailed him yesterday about that.
Yeah.
Okay.
It wasn't working for me either. He actually said that he got off on tech support and like on his end it was working, but then I got into a chat with Pearson. They sent it to like higher up person. So they're still going to email me back about that. And I can let you guys know, whatever they say. And I told him, I can at least pull it up in the top right-hand corner, but the problem with that is everything pulls up. So that's kind of my problem too.
Yeah, and one thing I will share today is the link to chat. You are chatting on the You didn't call them, right?
I'm sorry. Can you repeat that?
You chatted with them. You didn't call them. You had to chat with them.
Oh yeah, I had to chat. There was no phone number.
Yes, when I called the tech support yesterday, I was able to go through the line and I was able to talk to the real person because I'm an instructor. But I say, can you give me the 1-800 number or whatever the student can call just in case they say they do not have at the moment. So I say, so in this case, how will they do? They give me a link which I will share with everybody so that in case you encounter any issue, you can just chat with somebody. But I don't know, understand why you cannot get in touch with the real person. So the only thing you can get in touch with them is through the chat. But feel free to get in touch. I will intervene on your case. I will call them and say, hey, it's not working. So please.
If for some reason you can't, like for some reason like tech support can't pull it up, I do know that, you know, if we do click on the long list, you know, I can still take those quizzes and everything because I at least pulled them up to see. So maybe if it ends up not working, I mean, I guess maybe if you could like send out just like the exact modules that we need to go to from the long list.
Yeah,
or
even you can take a screenshot of what you are seeing right now. Can you see the screenshot of what I have right now? But I don't know.
Okay.
The danger of that is you may go in there and maybe I didn't pick up. Let's say, for example, in quiz number 9, let's say assignment number 9, I didn't assign you all the 100 questions. I only picked the question in there. So I have a feeling that also in dynamic study, you may have few selected questions, but you don't have to do all of them.
Right, exactly.
Yeah. So I'll still call them. I'll still call them this morning and find out what exactly is going on, because I say, can you just look as if you are a student in my section, say everything is signed up. I say, is anything I didn't click in assigning? They say everything is perfect. And even you can see right now on your my screen that they are available, but when you click, I don't know why, you know, you cannot see, you know, since I'm not enrolled, I've not taken, you see what is showing right now, you know. So let me just get back with you on that, okay?
Okay.
And
Great, thank you.
share the link. I'll also share the link for chatting with them. All right. Any other question?
Nope.
All right. All right, the class is dismissed. Then we'll meet next week. In case of any development, I'll let you know. For somebody, I'll still find out from the bookstore what is really going on. I know some folks, they say they were emailed the access code, but I'll find out and make sure that we are all on the same page. Have a wonderful afternoon. I'll see you again next week. The class is dismissed. Thank you.